In this video, we're going to talk about the limit comparison test. So the limit comparison test, we talked about it at the end of the last video, and we would use the limit when the direct doesn't work. So for example, let's say we had our given series, so that's our a sub n, and we chose our b sub n, and we said b sub n converges. So b sub n converges. So we would want this to be above my a sub n, but let's say it was below it. So if your b sub n is down here, and it converges, that doesn't tell me anything about a sub n. That's when we would use the limit comparison test. And the opposite is true as well. Let's say this is my a sub n, and then I choose b sub n, but it diverges. We need it to be below, but then let's say it's above. So b sub n would diverge. It doesn't really tell us anything about a sub n, so we're going to use the limit comparison test. So to do limit comparison, you're going to divide your a sub n by your b sub n, and as long as you get L, which has to be finite and positive, it does whatever your b sub n does. So just because it converges, just because we get a value, so let's say we get a value. If my b sub n diverges, then my series is also going to diverge. So that's the one little caveat to it. Just because you get a value doesn't mean it converges. It does whatever your b sub n does. So if b sub n converges, then my series converges. If b sub n diverges, then my series diverges. So what are we going to compare it to? That's going to be my b sub n. So for this one, b sub n, I'm going to pick the highest thing on the bottom. So we have 1 over n squared. For the second one, my b sub n is going to be 1 over root n. And then for this one, you're looking at n squared over root n. You want to take the highest function from the top and the highest function from the bottom. So now when I simplify this, we're going to get, so it's n squared on top. You get n to the 1/2 on the bottom. If we subtract exponents, we're going to get to the 1/2, which is 3/2. So it's n to the 3/2 for that one. And then for this one, we've got our b sub n, which is 1 over 2 to the nth, or 1 over 2 to the nth. Determine convergence or divergence, so b sub n. We're going to get root n over n squared, which is n to the 1/2 over n squared, which gives me the 3/2 on the bottom. So we get 1 over n to the 3/2. So that is my b sub n. We're going to divide a sub n, so limit as n goes to infinity. So a sub n, so root n over n squared plus 1 over the b sub n. So because it's a fraction, I'm going to do state change flip. So we're going to get n to the 3/2 over 1. And I will evaluate the limit. So we've got the limit as n goes to infinity. N to the 1/2, n to the 3/2 is n to the 4/2, which is n squared on top. So if I just multiply this times that, and then we get n squared plus 1. We're doing limits at infinity, so this is equal to 1. So just because I get 1, that's not the answer necessarily. Because I get 1, I go back to my b sub n. I need to determine if this converges or diverges. This is p series, so p is 3/2, which is greater than 1. So this does converge, so therefore this also converges. So we would say that the limit, I'm sorry, we wouldn't say that. We would say n equals 1 to this. So this is the original function. We would say this converges by the limit comparison test to So you could leave it like that. If you want to take it one step further, you could say because p equals 3/2, which is greater than 1, but you don't necessarily need to show that. At this point, I hope that you have an understanding that for p series, if it's larger than 1, it converges, and for geometric, if it's between -1 and 1, it converges. So at this point, you don't necessarily have to write that, but you do need to answer the question. You need to say why it's converging, and it's converging because of the limit comparison test. For number 2, I would be okay on a test if you just put diverges. If you're really paying attention here, we know that the limit as n goes to infinity of n times 2 to the nth power over 4n cubed plus 1 does not equal 0. So this does not pass the nth term test. So this does not pass the nth term test. For number 3, I'm going to choose my b sub n. So b sub n is going to be 1 over n to the 2/3 power. So p is equal to 2/3, which diverges because 2/3 is less than 1. So I know that this diverges. So if I get L, when I do the limit as n goes to infinity, my answer is going to diverge. Okay, it's going to diverge. So let's go ahead and do it. So it's a sub n. So we've got the limit as n goes to infinity, my a sub n. So it's 1 over the cube root n squared minus 2 divided by b sub n. So we get n to the 2/3 over 1. So we've got the limit as n goes to infinity, so it's n to the 2/3 over like that. So look at the highest exponent on the top and the highest exponent on the bottom. So it's going to be the coefficient, so it's 1 over 1, which is just 1, equals 1. So that means it does whatever this does. So my final answer here would be so this diverges by the limit comparison test to the p series. So you could again stop here. But again, it's important to note I had a student one year, they kept putting the wrong explanation as to why the original is converging or diverging. It's converging or diverging because you're using the limit comparison test. That's why, not because of a p series. Okay, if you want to state why this is converging, you can do that. You can say because you could say that p equals 2/3, which is less than 1. So this diverges as well, but that's not really necessary. You're answering this question. This question's asking you if it's converging or diverging. It is diverging by the limit comparison test. And then for the last one, we've got b sub n, which is 1 over root n. So again, we have p is equal to 1/2, which is less than 1, so this does diverge. So we're going to do the limit as n goes to infinity, a sub n over b sub n. You could flip it, so root n over 1. So we've got the limit as n goes to infinity, root n over root n plus 1. You take the coefficient because the exponents are the same, which is 1. So it does whatever that does. So I would say that the original function diverges by the limit comparison test to, and I'm going to write my b sub n here, so 1 over root n, n equals 1 to infinity.